It's got fractions in it, like 63 on page 92. That's right. All right, is that a plus? Yes. Ladies and gentlemen, I could use my two steps. Find a common denominator, which is going to be what?
X plus 4.
X plus 4. Multiply every term by x plus 4, including the 2, and then I wouldn't have any more fractions. Anybody see another way you can approach it? What you see?
Move the -2 across the equal sign. That way, on the other side, you have a common denominator. You won't have to do anything.
All right, so did anybody notice that we already have a common denominator with my two fractions? Can I combine those two fractions since they have a common denominator? Yeah. I can combine those two guys since I have a common denominator. Those two guys, they'll combine already. Now my other approach will work. It will work universally, so it's always very nice. So I can go ahead and combine these guys. That's x plus 4 over x plus 4. And you suggested moving the 2 over. Be fine. All right, let me ask you a question, ladies and gentlemen. Let me take you back to chapter P, all right? I know this will take you back into your distant past of last week, but look at that original statement, x over x plus 4 plus 4 over x plus 4 plus 2 equals 0, and let me ask you a question. What's the domain of x?
X cannot equal -4.
I'm sorry, what?
X cannot equal to -4.
X not what?
X cannot equal to -4.
Thank you. Did y'all remember that? If I got a fraction, I have to ask myself the question, is there something that would make the denominator 0? Yeah. -4 would make the denominator 0. So here's what I better do. I better put a little note over here to myself. X is not equal to -4. Okay? X is not equal to -4. And do you know why I do that? Because if I get to the bottom of my solution, if I get to the bottom and it says x equals -4, I go, wait a minute, x can't be -4. Hey, what would I do? What would I do if I solved this thing and it said x equals -4, but my note to myself reminds me that x can't be -4? What would I conclude? No solution. If the only solution that's possible has been eliminated by my note to myself, then there's no solution. That's why you put that note to yourself, all right? Just to be safe. Because there will be instances, I promise you, when you will solve a problem and you get x equals -4, and you go back and go, oh, wait a minute, x can't be -4. So you will choose not the option that says x equals -4, you will choose the option that says no solution. All right? So let's see. X plus 4 over x plus 4, that's the same as 1. So I have 1 equals -2. 1 equals -2. What do I do in a situation when I get a universally false statement like this?
No solution.
No solution. Very good. Notice there's no x's left. No x's. False statement. Implication. No solution. Okay? Is that clock still right?
No,
It's already wrong?
yeah,
What time is it?
16 acres.
Oh, it's 16. It's lost 2 minutes. All right, let's go on. The next section is modeling. What did I say modeling was going to be about? Word problems. So we're talking word problems here, ladies and gentlemen. Word problems that translate into linear equations. In other words, we're going to be looking at a paragraph of information. And when I take that paragraph of information and translate it into mathematical symbols, I'm going to get something that looks like that. I'm going to get a linear equation. Typical equation. And literally, it is a translation. Just like those of you who are taking a foreign language will oftentimes have the challenge of, here is a paragraph in Spanish, translate that into a understandable paragraph in English, or vice versa. Literally, we're going to have paragraphs in English, and we're going to translate them into mathematical symbols. Can somebody think of an English phrase or word that has a mathematical equivalency or translation? And what would that be? Plus. Okay, you got the idea? And, plus, what else? Less than. What's it translate to? Going to be subtracting. What else you got? Increasing. Also what would increase translate to? Could be addition. If you increase something by 7, you increase it. That's a plus. If you increase it 4 times over, that's a multiplication. Anything else? Got a twice something? Okay.
Product.
The product of, yeah, sure, multiplication. Okay, so we will be seeing more and more of these phrases or words that translate into mathematical symbols. And the best way to start talking about word problems is to work some word problems. So with that in mind, let's go to website. Let's do the student view. Let's do you guys. And let's do modeling linear equations. Let's start working some. Okay. Write a verbal description. Translate. Write a verbal description of an algebraic expression without using the variable. Everybody look at those different options. Don't say anything out loud. Just look at those different options. Notice a number or the number is Q in this case. Yes, ma'am, what you think? And can we turn the front lights on? I think that's the back switch. I'll be good. Don't worry about me. Just think of yourself, okay? Okay. Yeah, okay, that's good. Y'all see it better? Anybody got a choice? How many would go for A? Anybody go for A? Anybody go for B? C? D? And the other 80 of you, what would y'all do? Holy macaroni. Talk about